Now, what is more fun than slides? Well, obviously the swing, but there's no swings here. Also, staying inside and learning about the wonders of the universe, like electricity. Boy, don't you just want to do that?
Now that you've already learned 3 letters of the alphabet, namely the the I, and the R, we can get weird with it. Let's get a metaphor going. I said before, metaphors eventually break down. But I like slides. I just really like slides. I can Photoshop myself on slides. I can actually go off slides. I like slides. Not as much as swings, but I like slides. For explaining electricity, I also really like slides. Some people use waterfalls, other people use water pumps. I like using slides. Remember these guys? Of course you do. If you don't, watch the previous video. It's called Ohm's Law. These guys are a metaphor for explaining electricity. I'm going to be using slides as well. So I'll be using 2 metaphors actually. I like slides more because they are more extensive. Anyway, let's compare the slides with these 3 boys or girls. We have something that pushes our current, which is the voltage. And here it's a person pushing another person, and with our slides it's gravity pushing us towards the earth. We also have something that's being pushed, and with our slides, let's just say it's the person going off the slide. We also have some amount of resistance. Let's just say that that is the width of the slide. The wider the slide, the more people can go over the slide. There's less resistance to go over the slide. We can make the slide real thin so hardly anybody can actually go on the slide, or we can make it really wide so very many people can go over the slide. So we can see that if we change our resistance, the width of our slide, the current also changes. Now, to get you to make a more clear mental image of this idea of these slides, answer these questions. What could the slide look like if there was a high voltage and a high resistance? 2. There's a low voltage and a high current. 3. There's a high resistance and a high current. This one's great. And 4. If there was actually a swing nearby the slide. As you might be able to tell, the metaphor breaks down, especially when you're doing high current stuff with lots of people just piled on a very thin slide. Doesn't really work. But what that just means is you have to push harder. I was talking about gravity being the push thing instead of the guy pushing. We're actually just going to hire some guys to actually push people down the slide if gravity does not provide enough pushage or force. So let's just say we can up voltage by just having people push people off the slide, which is totally safe, very fun to do. I recommend going head first. That's the best way to go off a slide. That's how I got so smart. The metaphor with slides becomes more useful when you're getting into splitting voltages or looking at using multiple resistors, which we will be doing in the next couple videos. So you can look back on this video to check what I mean with the slides. That's why I made a separate video about it. And as always,
While I am a licensed physics teacher, this does not make me an expert on the subject. I'm wrong sometimes. Sometimes I know I am, with simplifying my explanation at the expense of being completely correct. Sometimes I actually don't know. In either case, I've got a pretty good grasp on the laws of nature and how things work. For the purposes of these videos, the exact correct descriptions of phenomena is not important. I'm trying to give students a new way to look at this world with a technical and logical view. Please feel free to contact me to discuss any of the subject matter within the video.
have a good one.